We want to find some sample size. And I'm ready. Using our normal distribution, what are we trying to do? We're trying to see the number that we need to sample in order to get our errors small enough that we can put it in our reports. You ready? You ready? You ready? Let's use that idea up here. I'm looking for sample size. I want to see how many individuals, elements, trials I need to perform or survey or conduct in order to get my error within a reasonable range. So what am I trying to do? I'm trying to bound my margin of error by some number. Here, our margin of error, I'm putting this up in general. Why? Because you can use this for any of your margins of error to find out your n. So anyway, let's just do it for the normal distribution for now. My margin of error is my z alpha over 2 times my standard deviation. That's my notation for standard deviation because I tried. I can't make sigmas. Sometimes you got to throw your hands up in the air and say, hey, you got to let go. So then, this is my standard deviation and my notation for the standard deviation of a population. Yes, divided by the square root of n. I'm trying to get that to be smaller than some bounds. All right, I realize this is a stat class and you may not be algebra ninjas, but I want to solve for n. What? That sounds like algebra. I know. Let's go. I'm going to multiply both sides by the square root of n. I don't need to flip that y, because the square root of n is going to be a positive number. And then I want to divide by b, and I don't need to flip that y, because b is my bound on error, and I choose it to be some positive number. I don't want to have no negative error. You know what I mean? Anyway, performing this, like a Jedi. Z alpha over 2 standard deviation divided by b. That's going to be smaller than the square root of n. Yes. Now I'm trying to get n by himself, so I'm going to square both sides. Legitimate, because that's a positive number, we're going to be okay. Yeah. So then I square both sides, multiplying this side by itself, multiplying that side by itself, aka maintaining my equality. So then my sample size, z alpha over 2 standard deviation divided by my bound. Don't forget to square the dang thing, man. I put these things on exams and people get all here and all, but they forget to square it. And then always round up. That, of course, is when you have decimal answers. Sure. You're going to want to round up y, because you can't sample, survey, or conduct part of an experiment. Know what I mean? Let's see an example. On up here. Now we're trying to get our error to be within 3 units. Wait, you can't see that. That's too high, huh? Okay, we want our error to be between 3 units. What am I talking about? Maybe we're like, a package delivery company, like the Tan Van or something like that. Right. And we want to get our survey participants between 3 packages. What do I mean? I mean that we want to see how many packages get delivered to the wrong places at the wrong time, but we need to see how many trucks we need to sample in order to find out within a certain error that we are confident that. Let's find our sample size. So what do I need? I need to plug it in. I need a z alpha over 2. Let's talk about that. Here's a 90% confidence level. Yeah, so what's my alpha? My alpha, going to be 10%. Yeah. Or 0.10. Now that's the area in 2 tails. So we go to our z chart and we look up 1 tail, 0.05. Yeah. So then our z alpha over 2 is 1.645. Right. There's a complete and total video on how to find z values. So then I throw it up here. So then this is 1.645 times my standard deviation of my population. It appears to be 4 packages divided by my b, which is 3. That's the bound on my error. I'm going to square it, and that's going to be smaller than n. Yes. Ready? 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 I know I got a calculator around here somewhere. Oh boy. Where is it? My studio's gotten a little, you know. Oh, there we go. Ready? 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 Oh, bam. 1.645 times 4 divided by 3. Close it. Square it. Wow. We don't really need to sample that many. Is that true? True. It appears to me that 4.81 is smaller than n. Yeah, that's about. The decimal goes on. So let me go on. I'm going to choose. Oh. Yeah, he did. Choose 5 trucks. Now you're like, why did that happen? Here, our bound relative to our standard deviation, those were pretty close, right? This population usually varies by 4, so you can expect 68% to fall within, 4. That's one standard deviation. So we don't really need to choose all that many. Let's see another example, like down here. Our significance level is 0.05. So this means, that's a 95% confidence interval. For a 95% confidence interval, our z alpha over 2 is 1.96. I think so. You should probably check me on that. Yeah. So then we're going to have 1.96 times 0.25 divided by, my bound on error is 0.03. And then I'm going to square that guy, and that needs to be smaller than my end. So you ready? You ready? You ready? You ready? 1.96, parentheses, times 0.25 divided by 0.03. Close it, square it, don't forget to square it. Wow! Here, this is much larger. Here, this is 6.778, and that's smaller than n. So then here, I'm going to choose. Always round up. 2, 6, 7. What would a scenario in something like this be? Maybe you're looking for a population proportion of something that has a usual standard deviation of 1/4. Yeah, that's all I got for you. Study. Ask questions. Get grades.